Hey, going to try to walk you through a basic van electrical system here, how power works, how voltage works, and current works. So here's our setup in our baby van. We have a series of light bulbs here in a row. Most lights aren't actually going to be like this, but we're going to use that as a demonstration for something. Here we got, so those both are running off of a circuit breaker, which we're using for lights. And then here's another circuit breaker. We're calling this entertainment, laptop, etc. And over here, we have the fridge. So, okay, let's go back to let's zoom in on our battery here. So here's our battery. Generally, batteries, the negative terminal is grounded to the van. So since the van's made of metal, that can act as a wire. And there won't be a problem getting you electrocuted in the van or anything. Some builders may use a separate wire for everything. I tend to do that. I don't have that big of a system, but if you have a big system, you probably want to ground to the van. So here's my battery, and the color coding here is that the red, anywhere in the red wire, it's 12 volts from that red wire back to ground. Okay, so that's our color coding. So when I leave the battery, everything in here, we can think about voltage as pressure. It's basically how much energy is in each chunk of electrons going through there. So we're going here through the fuse. Usually we have a big fuse, and then I've just thrown in a current meter here, an ammeter usually called, and that's still on this heavy duty wire because that's running all of our currents going through there. So we need these really thick wires. And then usually there's a circuit breaker box where you've got a bunch of your circuit breakers. And so here we've got our three, and at this point they're all turned on. And let's first look through the fridge. Oh, let's go back to the other end. Okay, so this is grounded to the van. So then down here we have our bus bar, which is a big thick metal bar that your negative sides can tie into. Again, the thickness means it's not going to heat up. And so that's going to have a thick wire that takes it back to the grounding of the van. So let's go back and look at our fridge first. So here's our fridge wire. We've got a circuit breaker here. We're still at 12 volts. We haven't lost any energy to anything. Current meter is just in line. It's just something that tells us how much current's flowing through there. So we've got 4 amps of current flowing through there. And it comes down to our fridge here. And because it's a 12 volt system, power is how much energy per packet of electrons times how many electrons. So voltage times current gives us a power. 12 times 4 gives us, this is a 48 watt fridge. And the resistance in there, if you like physics, resistance is just how easy or hard it is for electrons to get through here. It's hard for electrons to get, it's easy for electrons to get through here. So a lot of electrons get through it and we get a lot of power generated from there. So that was a little bit thicker wire here. Because it's the fridge. Now I'm going to my entertainment system, laptop, whatever. It's not that powerful. I can go back to a thinner wire if I need to. Again, back here I've got this thick wire because this is still, it hasn't been distributed out yet. So now I've got a medium-sized wire, smaller wire, probably doesn't much matter with this. It's reading 400 milliamps or 0.4 amps. So 1/10 as much as our refrigerator is the amount of current flowing through there. It comes flowing down through here, goes through my entertainment system, and again, it's going to drop all the electrons back here, have no energy relative to the battery. So they're just kind of moseying their way back to the battery with no energy. Here they had lots of energy. They gave it up as they went through here, coming out in your laptop screen, your speaker systems, whatever else. So again, that's 12 volts from one side of that to the other. Both of these devices run on 12 volts. We got 2 more paths to look at here. We have, here's our light circuit. I'd suggest probably having 2 light circuits, so if one fuse blows, you're not totally in the dark. But this one just has it on 2. Often you'll run a bunch of lights off one because the lights don't tend to carry that much current. So we've got 125 milliamps here, or 0.125 amps. Again, even less than our power here. And here we can actually break it down into 2 different paths. So we're going to say, okay, one path here is a single light bulb. Now, we're all using LEDs. They work a little bit different than these, but for simulation here, it's going to work. So again, we've got 12 volts from one side of that bulb to the other. So that's our single bulb. It's got 1.2 watts, kind of a typical small bulb. And then here, last thing here, we've got a string of lights. Now this is the old style Christmas tree lights that if one goes out, they all go out. They're not usually designed this way, and we'll kind of see why. But so we've got 4 of them in series. This is called series if they're 1, 2, 3, 4 all in a row. And what happens here is right above this, we've still got 12 volts. Now, the electrons are going to give up their little bit of energy as they go through that. It's kind of hard to get through. They give up some energy. So now, if we compare this voltage in this wire back to the ground, instead of being 12, it's only 9 because we've lost some as it went through here, lost some potential. So again, it goes through the second bulb, it loses a little bit more potential. Now we're only at 6 volts from here to the base. Down here, we're only at 3 volts from here to the base. And here finally we're at the other side of this, we're at 0 volts from here to the base, to the negative side. So this is how circuits run. This piece here, the series, is going to be more important when we talk about batteries. And I will do another video showing you how batteries work as well. But here's your basic electric system for your van. Hope that helps.